Alright, so hello and have a nice day, Dr. Shama. So we will present about Wafer manufacturing. So I am SUFFIAN and my teammate is Muhammad Arif Faisal bin Muhammad AZMI. So the manufacturing process is the actually production of the wafer. So in this process, purified polycrystalline silicon is heated to a molten liquid, and then a small pieces of the solid silicon is placed on the molten liquid. As the silicon is slowly pulled from the melt, the liquid cools to form a single crystal ingot, and then the wafer is then processed through a series of the machines where it is ground smooth and chemically polished to a mirror-like luster. So we can see about the process is actually from the powder, which is sand, silica, SiO2 silica, and we will heat it to become a molten, and then it will go through a multiple process to get a polysilicon, which is we call as EGS, and then we will pull it and we will do some polishing and we will do some slicing to get the exact size for us to manufacture for IC or transistor. From the wafer manufacturing, we can continue to use the wafer into the next process, which is IC manufacturing, and for the next microelectronic processes device. So that's all for the introduction. So we move to the process. Okay, first for coding. We use the bedrock first. The bedrock of the introduction of the first page, which is which is the cover page. So we just screenshot and we use it as a bedrock for the first scratch, and then the coding. For the coding, we just when a green flag is clicked, so we just switch the bedrock from the firstly we use the bedrock, the black bedrock, because we want to talk about the introduction of the manufacturing. So next we use the industrial bedrock because we want to make such a conversation between Avery and Devin, which is Avery is want to learn about the wafer manufacturing. So Devin will explain to her what is the manufacturing is, what is exactly the wafer manufacturing. And so we include some sound to make the stretch become more interesting. So we just download the video from the YouTube and we convert it into MP3 and we put it in the coding. So it will start from the from the first minute of the scratch until the end of it. And then for the coding, we just use simple conversation. Coding between Avery and Devin, we use simple conversation. And then for the manufacturing process, so we move to the wafer manufacturing process. So for the first step is reduction process, which is the sand, which is SiO2, will be heating at 2000 degrees Celsius to transform the sand, which is SiO2 silicon oxide or silica, to a crude silicon or MGS, which is stand for metallurgical grade silicon. So for the next step is silicon purification, which is which is we also heat the crude silicon or MGS at the 300 degrees Celsius. But MGS must be grinded into the powder. So the powder, MGS powder, will react with HCl, which is acid, to form a trichlorosilane, which is a uh, which is a chemical. And then we will do another silicon purification to get the EGS, which is electronic grade silicon, and it is a polysilicon. And we will heat it at 1100 degrees Celsius. And then we move to the crystal pulling, which is the EGS, which is molten, will be heated at the high temperature, and it will pull using a single crystal silicon seed. So we have two methods, which is floating zone method and the Shorselski method. To get the road shape of the silicon. So which is we call ingot. So the ingot, we will polishing to remove the grooves, and we will do wafer slicing to cut it into small pieces. And then at wafer finishing, we will polish the edge, we will lapping it, and we will do it ready to do another process. So that's all for wafer manufacturing process. Thank you.
Okay, now I will explain to you about the coding part, which is the coding part is the important part in the Scratch. So we decide to use two main character. I and my friends decide to make a use of two main character. To easy our work, we choose the character that provide by Scratch, which are Avery and Devin. We set Avery as a student that doing a site visit to the semiconductor factory, and we set Devin as an instructor that have to explain to Avery about the process of wafer manufacturing. Okay. The coding for Devin is quite complicated because Devin have to talk a lot, have to give information to Avery. Different from that, the coding for Avery is quite simple because Avery is not talk too much. Okay. Each coding represent one sprite, and for example, when the green flag is clicked, some sprite will appear and some sprite will disappear, will hide, and the sprite also must follow the timing that we code for the background, and they will appear at the background and at a certain background and will hide at a certain background at another background. Okay, so I will explain to a little bit function of the code that we use for coding the sprite. First, we assign the event function. The function is for will make the sprite to appear at a specific background that we set earlier. This is for the sprite to appear at a certain background, desired background. Next is we use the motion function, which is go to x is equal to 200 and y is equal to negative 61. This function is to make the desired sprite to appear or move at a certain location. This function also make the sprite look tidy and arranged. Then we commonly use the wait function, which is to make the sprite not to overlap each other when they are talking. And we also use a speak function in order to make the sprite every sprite that have text turn their text to speech, and this will make they look like they are talking. And lastly, we put hide function at every coding sprite hiding to disappear the code is when to disappear the sprite when the code is done, and reappear when we use the show button. And to make the scratch not so boring, so and look more attractive, so we could for sound at the beginning when click the flag button. That's all from us. I hope you understand that every the explanation from us. And so we look at the simple scratch project that we prepared earlier on this topic.
The manufacturing process is the actual production of the wafer. In this process, purified polycrystalline silicon is heated to a molten liquid. A small piece of solid silicon is placed on the molten liquid. As the silicon is slowly pulled from the melt, the liquid cools to form a single crystal ingot. The wafer is then processed through a series of machines, where it is ground smooth and chemically polished to a mirror-like.
Hello. Where are you from?
Hello. I'm from Dr. Sharma's class. We learned about wafer manufacturing in microelectronic. I would like to study about it in details. It seems interesting.
Let's go to the factory. Maybe we can learn some things about it there. The first process is polysilicon stacking. This process is for filling high-purity polycrystal silicon in quartz crucible. Next is ingot growing. This process is where polycrystal silicon is melted in high temperature then grown into single crystal. Then step 3 is ingot grinding and cropping. This process is for making the surface of ingot smooth and cropping into blocks. Then step 4 is wire sawing. This process is for cutting the ingot block into single wafers. Step 5 is edge grinding. This process is for shaping the edge of the wafer. Step 6 is lapping. This process is for making the surface of the wafer smooth and flat. Step 7 is etching. This process is for eliminating process damages on wafer surface using chemical reaction. Step 8 is double-side grinding. This process is for removing small bumps on the wafer surface. Step 9 is polishing. This process is for removing fine bumps on the wafer through precision processing. Step 10 is cleaning. This process is for eliminating impurities on the wafer surface. Step 11 is inspection. This process is for inspecting the quality of wafer such as shape and flatness. Step 12 is particle counting. This process is for inspecting defects in wafer surface. Step 13 is epitaxial growing. This process is for adding silicon single crystal layer on wafers. The last step is packing. This process is for packaging the product to protect it from shock, dust and humidity. That's all the process of wafer manufacturing. Hope you understand the process.
I think I understand all the steps that you explained just now. Very detailed. I hope I can apply this knowledge for my microelectronic subject. Thank you, sir, for the explanation.
You are welcome.